Okay, people are joining in. Okay, it's time for our second keynote of ICFP. Before I let Ron introduce Elena, a small announcement. To foster a bit more interaction and have a bit more of a hallway track, we added a virtual lunch and virtual dinner. Right after the keynote, you can have a virtual dinner, go to the lounge, grab a table, there will be tables prepared, and you can have a virtual dinner there. And then a couple of hours later, with an ICFP first, you have lunch after dinner. 3 hours later, same deal, before basically the mirrored program begins. With that, Ron, take it away.
Thanks, Leo. Welcome to the second day of ICFP main program. And it's my honor to introduce our second keynote, which is by Elena Glassman. Elena is an assistant professor at Harvard University, as well as at the Radcliffe Institute for Advanced Study, where she specializes in human-computer interaction, HCI. So she earned her PhD from MIT and was a fellow at the Berkeley Institute for Data Science. And Elena, in her own words, aspires to create tools that augment human intelligence with computation. And among the tools that she uses to achieve this is a raft of programming languages technology. But this grounding in HCI and an appreciation for programming languages gives Elena a valuable perspective on what this community has to offer, computer science construed broadly. So I look forward to hearing from Elena about how to build PL-powered systems for humans. Elena's talk is pre-recorded. We have plans for a live Q&A, and we'll be bringing her onto the stage at the end of the talk to answer questions. So I'll take it away, Leo.
Hi everyone, my name is Elena Glassman and I'm an assistant professor at Harvard. I'll actually be in residence at the Radcliffe Institute for Advanced Study there at Harvard this coming year, so I want to acknowledge their generous funding of that time to focus on research, much of that research of which is at the intersection of human-computer interaction and programming languages, which I believe is why I have the honor and the pleasure of being a keynote speaker here this year. I graduated with a PhD that was an amalgam of papers published at HCI venues, and so I still think of myself as a researcher in human-computer interaction. But even during my time in HCI as a graduate student, I was in the same area of the building as PL folks, and I collaborated with Rishabh Singh actually on one of my big projects. We didn't do synthesis, we just did some program analysis together to render large collections of programs more effectively for human consumption in large programming environments. He was simultaneously working on some of his work synthesizing automatically generated corrections to buggy student programs in these massively open online courses. But I didn't understand the power and the possibility of PL-backed interfaces until my postdoc. The condition of accepting the postdoc offer was that I needed to do at least one PL-related project, because the funding was through EXCAPE, the NSF expedition grant for a collection of, I think, mostly program synthesis developers and one HCI, primarily HCI person, which was my postdoc advisor, Bjorn Hartman. So I thought, yeah, sure, I can do that, right? And then when I got to the postdoc, I realized that especially synthesis in particular from PL technology was this hammer that I didn't know I needed, and so I kind of set out to understand what synthesis could do today, what it could do next year, and what utility was being missed out on because we weren't thinking as hard about the interface, maybe, as we were thinking about the next greatest algorithm. I'm going to talk about two things. First, interfaces that I played a major role in helping design that are backed by PL technology, specifically synthesis. And second, I'm going to talk about challenges, the challenges of designing for humans in a conversation with my guest Nadia, who's a member of the ICFP community. The first two projects I would like to highlight were actually published together because they use the same underlying state-of-the-art synthesis technology, which was learning transformations over programs. But we built two different interfaces for two different workflows by which instructors in massive programming classes could gain better insight into what types of mistakes their students were making, and also propagate both now to all the relevant students and to all students in the future who had a particular bug, some teacher-written feedback. The specific problem we dug into was that automatically generated feedback that scales to very large programming classrooms was also formulaic, mechanical, and not really anchored to the course context. It might be like on line 2, reconsider variable initiation, something that could be generated with templates after some program analysis or even program synthesis that looked at different ways you could modify the program to get it to pass all the test cases. So our key question here is, how could we use program synthesis to help scale their own teachers' feedback, which could be conceptual and contextually anchored in their course? The first system was able to meet this challenge by incorporating a mixed initiative workflow. We called the system Fix Propagator, and I think you'll see why. Of course, it starts with the standard setup where a teacher is providing some test cases associated with an assigned problem, and students are submitting their code, often incorrect. Here's where it gets interesting. The teacher is going to pick an incorrect submission and demonstrate what fix they would apply to that student submission, as well as what conceptual hint that they might provide. Like, hey, remember lecture 5? It's not right to do the following. That single fix and handwritten note kicks off an entire process in the underlying synthesis-powered system that learns transformations, generalizations of that specific demonstrated fix to one student program. These learned program modifying programs can then be applied to all the other incorrect student submissions to see if it fixes them too, such that they pass the test cases. Now you can essentially cluster student solutions here for the teacher according to what bug fixing transformation learned from their demonstration that happens to fix them all. Now the teacher can go through and see that their handwritten note for that one student, maybe the fix got generalized to fix a bunch of other students, but maybe it's a mixture of different conceptual problems. In that case, the teacher can provide modifications to further clarify how that demonstrated fix, when it should and shouldn't be applied, and exactly what feedback should be propagated to the students who are fixed by one bug fixing transformation versus another. When they are satisfied that they have this anchored conceptual feedback for a fair portion of the class, they can send it back to students in their current class, and they can also hold on to those bug fixing transformations with the handwritten notes attached to automatically send those handwritten notes to future students if their future incorrect submissions are fixed by them as well. Now the second different interactive system that we built on top of the same state-of-the-art work was called Mistake Browser. So here's the workflow for Mistake Browser. It's a little bit simpler here. Students start submitting their code in response to the posted assignment that came with some test cases from the teacher, and the system starts learning transformations from the differences between incorrect submissions from one student and subsequent correct submissions from that same student. So from these example pairs of incorrect to correct, the underlying synthesis system learns transformations that fix both that program and are generalized to fix potentially other student programs that are buggy. And just like in Fixed Propagator, right, we cluster the student solutions according to the bug fixing transformation that fixes all of them. And when I say cluster, we're not talking about dots on in some abstract two-dimensional space. We're talking about just a list of student programs with the diff rendered such that the human can go through each one and confirm, yes, this is the same underlying conceptual issue. Now, for each conceptual issue that the teacher understands, they can write feedback for that cluster and have it automatically sent back to students who both now and in the future submit incorrect code that is fixable by one of the learned program transformations in the system that has feedback attached by the teacher, either in this semester or a previous semester. An important distinction between this interface and the Fixed Propagator interface is that here the teacher does not need to kick off the sense-making process and the setting up of customized feedback propagation with their own demonstration. They can, because they're getting snapshots of students as they progress towards correctness, the system can suggest a big picture view for the teacher without the teacher having done anything initially, right? So the teacher, after uploading the test cases, can come back and see this display of common mistakes that are fixable by the same generalized bug fixing transformation for them to then maybe respond to it in the following lecture. Hey, a lot of you guys are making this this mistake. Maybe let's go back over this concept, right? So the idea here is not as much, though it does support automated feedback to students currently and in the future. The focus is more on augmenting the teacher's intelligence and their kind of awareness of the programs and the misconceptions that their students have as revealed through their programs. I want to call out explicitly that I'm an interface designer, or at least I call myself that, and yet I've shown you no interfaces so far. I'll just point out that the real value here is the mixed initiative combination of human and program synthesis-based machine intelligence, right? That we don't need to come up with, though it's fun to come up with novel interface affordances, we don't need to come up with novel interface affordances to create novel utility and more useful and usable PL-backed systems. If we think really carefully about what the roles of the system and the human are. In this case, we wanted synthesis not to replace the human, but to amplify the human's effort and to augment their ability to see into what otherwise would be a pile of messy, incorrect student solutions. Now, in the interest of time, I'm going to do a whirlwind tour of our latest 3 papers on interactive synthesis and interfaces that make it easier and more effective for humans to use. First project I'll highlight is interactive program synthesis by augmented examples. So what you can see in the middle here is actually Gila Peleg's prior state of the art, allowing people to annotate the synthesized programs with, hey, keep this next, in the next round of synthesis, or exclude that operator. In comparison, we introduced augmented examples where you're able to highlight components of each example and say, this, I specifically mean a plus sign. This means any number, right? So you can highlight things as literal or general within the example with an annotation instead of trying to get the program to correctly infer that from giving many examples that vary in certain ways and are constant in others. The final cool piece about this work is where we, rather than putting the onus on the human to simulate how a synthesized program would behave on similar and also maybe even very different potential new inputs, we do that for them by analyzing the structure of the regex and generating examples that are similar and to the examples that they gave already, and also that highlight corner cases where there might be slight differences between various candidate regexes for them, or just behavior that they might not have anticipated. So again, thinking about what is the labor that is easy for the computer to do and hard for the human, and what is easy for the human to do, like annotating examples instead of reading synthesized candidate regexes and doing expressing their preferences there. With those extra novel affordances, we found that People in our user study were better able to generate correct regexes in response to questions that had been previously posted on Stack Overflow about how do you make a regex that. However, we noticed that we were still violating some basic usability heuristics from HCI, specifically the visibility of system status. So when the synthesizer was taking a long time, it wasn't really clear what effect their additional examples were having and the feedback they were giving it. We decided for our next project to focus on this particular heuristic. These are Nielsen's 10 usability heuristics. There's certainly many heuristics you can have. These are some of the most common, and I highly recommend them when thinking about designing your next interface. To make that system status more visible, we created 3 additional interface elements for the same regular expression setup, same backend. This one shows over time the number of candidate programs that are being tested in the order that they're being tested, and also the height of this here is showing how many of the user-provided examples are satisfied. So you can see that the system is exploring a space. The person can see that a lot of programs have been tried. There's kind of a ceiling in terms of how many examples have been satisfied so far. It's kind of the heartbeat, I like to think, of the system. Now you can see here, this is a second widget that they can look at, which has a sample of regular expressions that satisfied the most number of examples so far. So they can get a sense of, what are the best candidates so far in the synthesis process. Finally, the highest level of fidelity that they have is this visualization of the entire search tree. So this was representing the tree of programs explored so far, and you can see that the darkness of the node indicates how many nodes have been visited with underneath that node. If the user recognizes that the system is spending a lot of time exploring programs that start with one particular operator, and they know that that's not the right way to go, they can right-click on the node and say, never try the synthesis path again. Or if there's a place where they want the system to spend more time exploring, they can say, prioritize exploring programs that include this node. And they can do that at any level of the tree. This is a spectrum of levels of kind of fidelity to the underlying search process, and depending on your comfort thinking about these things, you may gravitate towards one or another. What's not shown here is that for those examples that the user provided, you could also show them the percentage of programs tried so far that satisfied each of them, so they could get a sense of, oh, this example, nothing is ever satisfying this. Here you can see the distribution over the different user-provided test cases, how many of them are satisfied by the candidates synthesized so far. And also down here, you can see if you select a candidate in the the overview that I just showed you, it will show you which ones it passed, it satisfied, and which user-provided examples it failed to satisfy, like this one. This can help people reduce that gulf of evaluation between what the synthesizer is doing or failing to do and the spec that the user provided. So we found that by adding affordances that increase the visibility of the system status, users were able to work with the synthesizer to generate correct regexes for the hardest questions that were posted on Stack Overflow about how to create regexes for particular purposes. This is a great example of how a usability heuristic from HCI could really expand the utility and usefulness of existing state-of-the-art synthesis technology. Now, I'm just going to tease you on an upcoming publication. It is called Assuage Assembly Synthesis Using a Guided Exploration. So we've moved on from regular expressions to synthesizing small assembly programs, which could be in a language that the participant or even the user in the real world doesn't know very well. It's difficult, challenging. This is a place where synthesis could potentially ease the burden on the user. We found that it did, and here's the really cool takeaway. It's that users could not only handle, but also preferred and performed better when managing multiple synthesis threads. Now, if they gave a combination of spec components that tanked the synthesizer, no worries, because there's other synthesis threads going on in parallel. Essentially made them less anxious about the spec that they were providing. They were less vulnerable to giving a conflicting spec. So it felt a little more playful, and they were indeed more successful. So look for that upcoming at WIST 2021. All right, so that was a whirlwind tour of the role that interface design can play in building useful and usable interactive synthesis systems. Now let's go talk to Nadia. Well, thanks for joining me on this.
Yeah, I'm still not sure what I'm supposed to do, but let's see if I can figure it out.
I've been working with two students who, one of whom took my Nadia Amin / Elena Glassman co-created PL HCI crossover grad class where we met together. And so one of the students from that class started trying to understand why human-centered prototyping within the domain of creating new synthesis systems, like what was uniquely hard about that? Was it a lack of knowledge about prototyping techniques, right? Was it incentives in terms of like what evidence is found to be convincing in the PL community? Or was there something about building a synthesizer that was just like the techniques that we had to offer from HCI were just like, yeah, cool, thanks, right? It's not going to work for me.
Interesting.
And so she started, and then with one other student, a new PhD student of mine, they interviewed 11 synthesizer designers who had published at least one system that was designed for human consumption. And so we're going to try and write that up for publication in the HCI community. But I thought when I got invited to speak to a PL conference, it's like, well, this might be the only time they hear about that, even though like we're studying members of their community.
No, certainly.
And you being someone who I know, like cares about the human experience, even as you are doing kick-ass PL contributions, I thought you'd be a great person to talk to about this, right? And to get your thoughts on what we've learned so far, and just talk about it as a more interesting way to present some of our preliminary findings.
Mm-hmm. Sounds good.
Maybe before I start telling you about what I learned from these interviews of other synthesis designers, I'd ask you a little bit to get you in the same brain space. Are you tech first? Like there's this really cool thing and I want to find out if it's possible. And then what problems does this solve? Or are you thinking about problems and then thinking, I've got this menagerie of techniques or new things I know might be possible? Which direction do you typically start in?
Yeah, so it's actually a really good question because I'm a little bit kind of feeling guilty about this because I know I should be more problem forward. I'm totally, but I think I'm totally the former. I get excited about techniques so much, and I'm like, especially if I see like two things that would really fit, well together. I was like, if we put those two things together, what would we be able to do? And then, trying to see what that would be useful for. Yeah, and I think many people in the PL community are like that. And that is maybe why, I don't want to speak too much for other people, but that is maybe why we sometimes go on those tangents that, inventing all these cool new techniques that then the users would find totally irrelevant.
I've felt different ways about this at different points in my career. And I think initially I was very much in your space as well. Like there's this really cool thing I want to build, right? How do I build it? And then, and I learned about user studies and like how to design interfaces and that form of gathering evidence. And at some point I realized that it was in my new community of human-computer interaction, like not okay to be tech first in a certain sense. And so I also had to like hide that aspect of like, well, I kind of really want to make this thing, but at least I would like do formative studies early on, right? Like I want to make this thing. Let me see if I can actually gather evidence so I can justify making the thing that I want to make.
Right. I think that's where I am now, basically, because, I realized that I would like to make things that people actually use, but at the moment, it's still more like that. Like I have this idea, let's round up some people and see if it works. And if it's not working, how do we change the setting in which we put those people to actually make them, like the thing that I want to build? There's still a little bit of that for sure.
Yeah. Well, now I think about it a little bit, actually harking back to my experience doing planning for robots, as like there's these various kinds of rapidly exploring random trees. And I like to think of the PL community as over here, like exploring in every single direction, like what is mathematically possible? How many different endpoints can I reach with the techniques and knowledge that we have, right? And then like kind of over here, if you forget about any particular technology with HCI, it's kind of like, what are humans capable of doing, right? What do they want to do? What are their goals? What do they struggle with, right? And then it's just, you want a healthy PL community creating all sorts of cool techniques, right, for the sake of new techniques. And some subset of them, right, are going to kind of be over here a little closer.
Yeah, there'll be like an intersection.
Right. And we want to like grow them together. And one thing that's worked for me well in the past, because I still don't consider, I myself am not a PL researcher. And I know there's many people working in this space who are on the HCI side, when you finding a PL person as essentially a teammate, an equal collaborator who is both a sanity check of like, yeah, that thing, you might think that's possible, but that is like a world of hurt away, right? like that's 10 years away. Whereas, and it kind of helps ground the brainstorming in terms of building the next best thing with the technology with it, which is within one or two technical papers grasps away.
Right. And I think you have been really successful lately at collaborating with synthesis people on, things that in the end result ends up being really, really exciting and really impressive, right? Because you bring this new perspective and then they bring the tech. Or at least, I'm a big fan of some of your recent work on both the interaction models in augmented user intent, and also especially giving users feedback after and during synthesis about what's going on, because that's the kind of thing that I always thought that would be amazingly cool if we could do that, but I never thought it was possible. And then like I opened this Elena's paper and here we go, they're doing it.
Oh, that's so funny. I thank you for the very kind words. And yeah, so much of that, the credit goes, of course, to the students who pushed that forward, and to Jinyu, who has been the collaborator on that work. There's so many basic HCI questions, right, that just PL research is ripe to answer, right, in terms of like for opening the box in the kind of like what's happening during synthesis. We're literally like, here's a snapshot of the programs that have been, here's a random sample, here's a tree of the space that's been explored, right, and even more basic, kind of a heartbeat, like it's still thinking. Here's how many test cases it's able to solve right now, right, and almost from an HCI perspective, it seems like, it's almost like that's so little that we're giving them. And yet the difference between having that signal, that information sent about what's happening and not, turned out to be hugely impactful in terms of where people could guide the synthesis to.
Yeah, this was fascinating to me, because whenever I thought about this question, I was like, well, how do we come up with some really fancy technology that will let the synthesizer know if it's on the right path, if it's doing something useful, and give the user those partial, solutions, partial results that it's so far come up with. And I was always in this dead end, because synthesis has this property that unless you have come up with a full solution, you never know if you're on the right path. But you guys came in with this more, HCI view on this problem, and like, well, we don't really need to know if it's on the right path. Just tell the users what it's doing, and they will find something, useful in that information.
I think that is something that I think like just generally applies a lot. Like when we're building technology, there's a lot of pressure for us to get it right? We want to write that ranking function that ranks the best program highest. We want the AI to be like, just look like it just got it. We then set really high expectations about how good it is, right? When in reality, we can actually be helpful, I think, to humans, even when the system is not as good as we wish it were, right? As long as that passing the baton back and forth, right, is low enough energy that it's better for the human to pass the baton back and forth with the computer than to just do it themselves. Mm-hmm. Right? And I think Jinyu had a really great tweet the other day, just saying like, yeah, it's great for us to build these better and better synthesis algorithms, and but also like we have to pay more attention to the cost of both to the human of providing the spec of what they want, as well as the cost of consuming the results.
Yeah,
I think that's where I'm struggling with right now is the costs of consuming the result. I often am like, I want to show them all the programs. I want to show them the entire space, and like this will like clearly be better. And I am not your typical user, right? And that's another thing that I think a lot of us like test our own systems. But actually, something that came up in the interviews with other synthesis designers was that the synthesis designer, when they were playing with it, right, they knew what it could and couldn't do, and they knew what it was built for, and they would give it inputs and say, look, it's working, right? And then reliably, anyone who described giving the system to someone else to play with, right, who was not aware of the technology, that person would use it for purposes they would never have thought of, right? Just because the person had no mental model, and therefore were not constrained by that knowledge that synthesis designer could not divorce from, could not flush out of their head. In your recent work, you're building for humans, right? Like, how are you dealing with the current challenges of building a synthesizer while also knowing that if you go too far without any human input, you might end up building something that's less useful and usable than you were hoping?
Right. So, I think I've started doing more of this, definitely human-centric and human-oriented work lately. And this is actually mostly thanks to Hila Pelek, who was a wonderful postdoc with me and now is faculty at the Technion in Israel. So she was the one who taught me how to do all this user studies. Otherwise, I wouldn't have figured it out without her. And it was really fascinating because of everything you say, you put it in front of users and they do something completely different from what you expected. And, things that frustrate them are not at all the things that you thought were difficult, but, something completely else. One thing that is actually kind of still bothering me as I'm doing this. So what we do, maybe I should describe a little bit what we do in those user studies, right? So, we would, I've done user studies for a couple of tools, but I think like the main user-oriented tool that we are building in our group is this tool called Snippy, which synthesizes small snippets of code for Python. In this live programming environment where inside your IDE, you have those sort of boxes floating around that show you the current state of your program. And then instead of just showing you the state, in Snippy, you can actually enter the state that you want to achieve, and the Snippy would try to synthesize a little code snippet that achieves that state for you. And so we've done a couple of user studies with that tool. And the thing that was a little bit disappointing for me is in those studies, right? So you get those users for 1 hour, and it's very hard to get people to stick around for more than 1 hour. And so all you end up testing is mainly whether someone can learn to use your tool in an hour rather than, if the tool would be useful to a developer over a longer period of time. So now we're actually really thinking about, how do we move on from those really short-term studies to more of a longitudinal study? Because I think, trying to do the short studies and to make them quantitative, because this is what conferences want. You sometimes end up not actually evaluating what you want to evaluate, because you're trying to just compare, how many problems you can solve in 1 hour, and then you end up picking, very small problems that can be solved in that period of time, right? And you want them to solve 3-4 problems in an hour. So this is, I think, the thing that currently worries me the most about this kind of human-centric, work on synthesis is whether we are measuring the right thing as we are doing these, short-term user studies. But I don't know, maybe you guys know much more about how to do those studies better.
I like to really lean into the qualitative insights. You're totally right that there's really no way to get around the fact that you're still testing kind of learnability of a system as opposed to ultimate utility. And you can kind of try to get past that by having like, a little tutorial video that they watch, right? That kind of thing. But, a 5-minute tutorial video is only going to get them so far. And so you're stuck in this early stage. And I still remember running a user study on a system that showed 100 different API usage examples all lined on top of each other at once to give you a sense of like the distribution over how that API call was used. And most, I think, out of 18 subjects, 15 people or 16 people got it right away. And there was at least one student who, as they were walking back out the door into the, the sunshine after an hour, said, "Oh, now I get it. Now it makes sense." And I'm like, yeah, all right. Well, it clearly, it was learnable enough, but there was still a non-trivial number of people who were going to encounter that system and be like, this is so radically different and inconsistent with what I'm used to that I couldn't learn it in an hour. So qualitative insights, I think that if you added that to those hour-long instances, you would get more value, though you can't yet get the longitudinal stuff. And I'm really curious how you're going to approach the longitudinal.
Yeah, I'm not sure yet. We're still.
Everyone, my name is Elena Glassman, and I'm an assistant professor at Harvard. I'll actually be in residence at the Radcliffe Institute for Advanced Study there at Harvard this coming.
Thinking about it, and maybe we will chat with you about that later. But I totally agree with you about the qualitative stuff. So I think what we found most useful actually by doing those studies were the pilot studies that we do before the main study, where we would first give the tool to people and they just let them play around with it and get their feedback on it. And also, all kinds of qualitative questions we would ask at the end of the main study, right? So, and, those insights I found much, much more useful than, just like how many more tasks the tool lets you solve.
Yeah, because it's just like, I think you can kind of quantify things, and then it's like, it's nice to have that result. If it kind of naturally falls out, it's really obvious. But, when you're trying to say like people are like 25% more faster, right? It's like, all right, that's like non-trivial, but also this is a really artificial situation, right?
Exactly.
And I hope that PL conferences have our I know HCI conferences are very comfortable with like very long qualitative, lots of quotes and that kind of thing. I hope that PL conferences are open to that kind of evidence as well.
Yeah, and of course it would be nice if they were more open to negative results in that sense too, right? Because sometimes it's just very surprising that this thing that seems so natural to me, like no one can use. I wish I could publish a paper about that.
Well, if you ever want to, I think the HCI community would welcome that in terms of like, humans cannot do the following, right?
Then it is not a negative result. For HCI, it's not a negative result because it's science, not engineering.
So I kind of mentioned this earlier on how traditional HCI, like if you walk into an introductory HCI class, you're probably going to be told to storyboard a problem, like try to understand all the obstacles, the goal that a user has and the obstacles they're currently running into. It's usually a goal that they already have and obstacles they're already encountering as opposed to a goal they could have should your thing exist. Is you're going to storyboard that, and then you're going to make some like wireframes, like interface that, and then you're going to put that in front of some people and they're going to point as if they're clicking on the piece of paper. Like, if you don't like your interface, you can kind of like draw a new one and do right there, right? Like low fidelity to increasing rounds of higher and higher fidelity until ultimately the system is like a working prototype that you're testing. It seems like in the synthesizer domain, as well as in the AI design domain, that process just doesn't make that much sense. First, for the reason that we've already talked about a little bit, which is that, we're trying to enable new things, right? So it's a goal someone might have if you remove the obstacles and they saw, oh my gosh, I could do that, right? And then also that the behavior, like if you think about AI or program synthesis as a design material, its behavior is really kind of like unknown to you. It's difficult to reason about. Mm-hmm. One, my student, Tyler Holloway, found this literature in HCI on exploratory programming and thought that might be a better way to describe a kind of healthy, but, synthesizer, knowledge-informed, human-centered prototyping approach, right? Like where people... some of our interviewees described building a teeny part of the language, right? And a synthesizer that was like the most basic unoptimized synthesizer for this teeny part of the language. And then, kind of iteratively with human, actual other people's user feedback, growing that. So they're always working with something that's operational as opposed to, kind of the traditional HCI thing of don't build it until the last possible moment, because then you'll get locked in. You won't want to throw away your code and you'll be stuck with a system that, you can't throw away.
Interesting. So you're trying to, so you always have a working synthesizer, but just for a tiny piece of like tiny fragment of your language, something like that. That reminds me of how the compilers class is taught at UCSD by my colleague Joe Politz, who's teaching this compilers class where they always have like a functioning compiler from week one, but for like a tiny language that has only one instruction or like one expression, 7. So it's a compiler for language 7, and then they just gradually build up.
Yeah. So this is how some synthesizer developers described incorporating more rapid rounds between the PL knowledge and the HCI knowledge. I'm curious about, it sounds like you are doing summative user studies at the end to evaluate. You might be doing formative evaluations at the beginning. What do you do in the middle as you are, trying to do this heavy lift of building a novel synthesizer without, kind of getting too far away from the human?
Yeah, so I think what happened in Snippy actually is that, well, it's interesting because what we started with, like the first version of Snippy, the synthesis technology was already there. So the synthesis technology was sort of an existing technique approach to synthesis, but so the innovation was just to combine it with this live programming paradigm, right, and put it in the IDE at like sort of at your fingertips, where you can very easily integrate synthesized code with program written code. So I think there it was easier because we didn't have to build new synthesis technology as we go. And as we were doing the studies for Snippy, then what we realized is that, so we're giving users those tasks, the users were running into Snippy's limitations. And one of those limitations was that it didn't really handle loops very well. It handled some simple kind of loops, but not loops with like dependencies in them when sort of various variables get updated inside the loop. And so this is how we sort of came up with our next milestone, where we wanted Snippy to work better when you want to synthesize some code inside a loop. And so at that point, we had to build some new synthesis technology that allowed us to do that. And this is a paper that is going to appear at UPSLA 21.
Congrats.
And then we would do another series of studies to evaluate that. So I think it was more of a sort of a cycle where you first build something, you evaluate that, you run into limitations, then at that point, you know what is the new technical challenge is, and then you try to build more. But as we were evaluating the second iteration of Snippy, which is called Loopy, because it does loops. So as we were evaluating that, this is where we really struggled with the UI part, right? Because building the system is really building two things, right? It's building the synthesis engine, which was easy in a sense, even though it was a new technology, but at least we knew how to do it. And building the UI was really hard, because this is where we needed this feedback loop with the users, because the thing that we built at first, literally no one could use. Like, we were trying to get people to do some tasks with loops, and like 0 people could use that tool to actually help them to synthesize anything inside the loop. They ended up just doing it in a different way or writing it all themselves. And so this was a long process of like doing pilot studies and talking to these people and asking them, what was confusing about this interface. And then I think by the end we figured it out. So people were actually able to get some mileage out of it.
Thank goodness. I think that what you're describing, it makes good sense as it's like, all right, well, I'm going to make a PL contribution. Like, this is a thing that didn't exist before in synthesis, right? If you had done no formative work, you might have found out, luckily you didn't. And I love the Snippy work. I'm looking forward to reading the Loopy paper, that, people couldn't use it. As long as people can use it well enough, right, that you can validate like, oh, the synthesis algorithm is useful, but, that summative user study validates what you did, but also points to the next technical bottleneck, right? And so you keep growing, growing the PL branches, right, towards, because each paper has that human-centered evaluation at that macro level, from project to project, you keep an eye on what people are capable of doing. And I guess in some projects, what you're asking people to do is complicated enough that there's a whole UI component that becomes a significant part of the contribution. In the ideal world, there would be better support, both tools to support and knowledge, such that, not just at the beginning and the end, but even throughout the development process, we could say like, hey, try this out, right? I think it increases the uncertainty we have about, whether in the end, that if we don't do any formative work or any, user input during the development, we increase the chance that we show it to someone at the end and then are like, oh no, like there's only one person that we interviewed. Yeah. It was just like that project, it just died. 1.5 years of effort and it just died.
Yeah, I think, what happened to us in the Snippy project is that some of the people that we invited to do the study in the first part of it, we couldn't quite use them for the final summative study in the second part, but they kind of became fans of the project. And then we kept inviting them like pretty much every week, like, look, we added this new thing. Can you try it? Right. So I think in the end, we did end up having feedback throughout the development because we formed like a little fan club.
That's awesome. I like that model of development, the fan club model. Let's see. I'm curious about if you've encountered this particular problem yet in your work in synthesis around correctness versus preference. So this has come up in my conversations with multiple system designers. Well, and there's also incorrectness that users have trouble distinguishing. If I'm looking at the some output that is generated for me, some things may help me pass the test cases, but actually be incorrect, right? Like it doesn't actually fix the bug. Some things may be different correct ways of doing it. So, one may be more in the style of your company. One may be more, kind of like as if you were writing in a different language, but, then there comes in preferences and kind of readability. There's actually one interviewee who talked about a synthesizer that was designed to be really, really robust and include a lot of things in the program that was synthesized on the person's behalf that would protect them from edge cases that many people didn't think about. And when they showed it to people, they actually preferred the less correct programs because it was more consistent with their conception of what they were doing. And the reaction of the designer was to turn down kind of the robustness ingredient to give them what they wanted. And I'm not exactly sure that's how I would have responded to that concern, but I'm curious if you see that in small step synthesis, for example.
Yeah, this is, I think, a really interesting problem that has traditionally been underexplored in synthesis, right? Because people were mostly thinking about the search algorithm itself. And, people were thinking a fair amount about how the user communicates their intent to the synthesizer, but about this feedback loop of like how the user comprehends the results of synthesis and how they would, figure out whether it's what they want and, pick between different results that they want. I don't think there is nearly enough work about that. We did a little bit of that work actually in our other project called Google Plus, where we generate, combinations of Haskell library functions that have a certain type. And because the input to the synthesizer is just a type, there's usually a lot of different options for you to pick from. And sort of one of the questions that we asked ourselves was, how do, beginners who maybe are not familiar with all of these library functions in the first place, how would they know which of the synthesized programs to pick? And then we built in, several affordances into that interface. Google Plus generates example inputs on which it runs those programs and shows you, some input-output behavior for those programs. What we found is that for experts, they didn't really pay much attention to those input-output behaviors that we gave them. So for beginners, that was more useful. We're basically generating inputs that would differentiate the different programs between each other, because we were like, well, you have to pick between 10 programs, so you need to know how they're different. But then it turned out that the user said, well, those inputs weren't so different because they were looking at one program at a time, and they were trying to understand what this program does. And then those inputs weren't necessarily representative. What they would really like to see is like some interesting cases in the behavior of that one function, as opposed to the differentiating examples between different functions. And we are still trying to figure out what are the best examples to show users.
You're trying to help them form that preference.
So this was my initial kind of mental model of a Haskell programmer, right? So we built this tool that mostly is meant for, just takes in a type, right? And we thought, okay, no one wants to provide input-output examples in Haskell because that's just too annoying. And, there could be some complicated data structures involved that are hard to put in and stuff like that. And so this is how we built the tool initially. But then when we did a user study with like a whole range of users with different levels of experience, right? So we had people who are beginners versus intermediate versus expert. Indeed, the expert users, that's the interaction mode that they use the most. They would just put in the type. But then it turned out that the beginners, not only they were willing to provide inputs and outputs, they would actually struggle to come up with a type, because Haskell types are, sometimes not very easy. And if you have an algorithm in mind, for an experienced Haskeller, it's very intuitive to immediately say, okay, this is the type of the function that I want. The beginners, on the other hand, they were struggling to come up with the right type. In the end, we built in this other mode of interaction into our tool in response to that, where you could just put in the input-output examples, and we would infer some candidates of what type this could be, right? And you cannot do it precisely because, maybe you put in examples where you're only using a list of integers, but the type that you actually mean is generic, right? You don't actually care that those elements are integers. So we would propose, several alternative types that you might have meant and for people to pick from. And we found that the beginners were using this feature all the time. And it was just so much easier for them to put in examples than types. And that was a surprising part for me of that study, because I always thought, Haskell programmers love types, use types, and know how to use types. And that's all they ever want to use. Not the beginners.
You're essentially observing in this Haskell process of gaining expertise, people becoming better and better at thinking about that underlying generality, as opposed to, well, I want to turn, X plus Y into this. It's nice that you are able to, rather than treat this as, oh, we need a separate interface for the beginners. It sounds like you actually built something that could flexibly allow people, as they gain that expertise, to continue getting value from it. Sometimes it's just so much easier to think concretely, and sometimes the general thing pops out, and it's
right. And that's another thing that we learned, actually, that we put all those different modes of interaction in, right? So you can do just type, you can do just examples, or you can do both. And then as you're getting results, you can look at documentation, you can look at, example usages, you can put in your own usages. And we thought, okay, this is way too many features. No way anyone would use all of them. And then it turned out most people used all of them. So I guess what we learned is, just give people some, different ways of doing things, and they will use them.
It turned out that when you gave people choice, they gravitated to what served them best. Right. And you could just observe, okay, well, under these circumstances, it turns out it's a lot easier to express this idea that they've got in their mind this way rather than that way. But of course, with each way of expressing yourself, there's always limitations, right? Sometimes you're giving concrete examples. I just want to say for all this, right? I don't want to keep giving more and more examples until it gets the for all part, right? And so I think, and that's actually something I think Jinyu and I are very excited about in this new NSF grant that we were recently awarded. Try to give as many as many different modalities, right? What does it take to provide as many different modalities as possible? Because this early evidence, both from our studies and from your studies, is that people can handle it. And
which kind of hurts me as a minimalist. But that's, that's what you learn from science.
I'm sure there's such a thing as too much. We'll find it. There's so much more of that interview with Nadia that I wanted to share, but time is not on our side. Thank you so much for having me here at ICFP, and I welcome all of your questions. If I can't answer them now, please feel free to email me, and I'll do my best.
Okay, let's thank our speaker very greatly. We're going to bring Elena onto the stage right now, but first I wanted to apologize for our technical issues. It turns out that even though we can send 2 gigabytes of data during a talk across the planet several times and get it into AirMate, technology doesn't work as well as we'd like all of the time, but I appreciate your patience. So we'll take a moment while OBS comes up. And what I'm going to do is go to the Q&A section. So if you have questions, put them in the Q&A tab, and we'll read them out to Elena, and she can answer them. There we go. Wow. This is amazing. Hello.
Hi, Ron. I've been here the whole time chatting with folks. I've seen some really great questions in the Q&A, and I'm happy to, as speedily as I can, answer as many of them as we can.
Okay, well then let's get right into it. Our first one is by Noon Vandersilk, which is to ask, do you have any general thoughts on how to allow users to navigate these high-dimensional choice spaces?
Right, comparing similar examples. So I think that the answer that I can give you so far, and it's definitely an answer that is in progress, is do as much automated pre-diffing as you can. Right. So I don't know if you are familiar. I flashed up Overcode, one of my first projects. We rendered, we were able to pre-difference many different student solutions with the most common solution. And so it was that much easier. People are really bad at kind of doing a visual diff between two things that are very similar. Computers are really good at it. So this is, pre-differencing and showing examples next to each other, almost as minimal pairs. Like these are almost the same, right? They produce slightly different output, or they're slightly different in an interesting way, but they produce the same output. These are ways that you might be able to take this high-dimensional choice space, as you call it, and render it in a more human-friendly way. But I mean, this is an ongoing question, active research question. It's really tough.
Awesome. Yes, I'm always muted. So our second question is by Rudy Matella, which is asking, regarding the system that gives feedback to students about mistakes that they might have made, what was the feedback you got from the students about the system? Like, did they like the feedback?
I love that you assume that we did a user study with the students as well. And I'm sorry to say that I believe that we did 2 user studies, one for both for Mistake Browser, one for Fixed Propagator. And we only used people who were TFs in the massive, like 1,000-person introductory programming class at Berkeley, where I was postdocing at the time. And so we were primarily concerned. The big empirical question was, were these were these bug-fixing transformations learned from specific examples, were they so broad that they were capturing many different conceptual problems, in which case the teacher would look at the list of each cluster and say, there's nothing in common here, I can't write some sort of helpful feedback? Or would the generalizations be very narrow and kind of like repetitive as slightly different variations of the same conceptual problem? We, in our user study with teachers that we didn't find either of those extremes. They felt like it was kind of a happy medium. But my assumption, my guess, and we'd have to empirically test it within our user study, is that students would hopefully prefer that handwritten note or hand-typed note from their teacher than what was the state of the art at the time, which was, literally like, you have a problem on line 2, right? Or change 0 to 1, right? Much more mechanical.
Great. Our next question is by Ilya Sergey, which says, tests and examples are the most widely adopted specifications for the synthesis, but they might lead to overfitting. So what more general and verification-friendly, of course, Ilya, styles of specification should we strive to make user-friendly in the future?
So I don't exactly know yet what's most verification-friendly, but I can say that I want to point back to that regular expression synthesis with augmented examples. This was an example of moving away from examples, but still being human friendly, because people were giving examples and then they were able to annotate the examples and saying, I'm giving you an example of a phone number, right? But it's not actually, none of these numbers in the example phone number matter, right? I can mark them explicitly as general, and I can mark how general. Is it a number? Is it any character, including punctuation, not including? So I think that annotations on a concrete example might be a way for us to move in the general direction in terms of helping users provide general specifications without increasing the onus on them, the energy that it takes to write a spec.
Great. So our next question is, how do you ensure that studies cover people with a representative enough background? So for example, Vim users like tools with large learning curves, but that have efficiency payoffs.
Right. Yes. And Nadia and I talked about this, that it's really tough to measure what the payoff would be if someone was interested in using it for the long haul and became a really expert user. For the moment, I don't know if anyone saw, I tweeted out a call for another user study for a new synthesis algorithm. And we do ask in the kind of demographics along with, say, gender and general age. We also ask, how many years have you been writing regexes, or how many years have you been programming? Things like that to see if we can't kind of find, maybe we can include some expert users, people who say, I've been doing this forever in my sleep, and people who claim to have very little expertise. And one other thing that we sometimes do, we introduce like questions from the need for cognition psychology. Actually, it's kind of trying to get at how interested you are in looking at the details of a problem versus so that we're trying to better characterize the diversity of people that we bring in, not because we can't ensure that we cover a perfectly representative sample, but just that we understand who it is that we're bringing in for each session, where they're coming from, how they react to the tool. And if the tool provides many different ways of specifying things or many different ways of showing what's happening, as Nadia and I were saying, they tend to gravitate toward what helps them best.
Great, thanks. And for our last question is by Julia Belyakova, which says, are there non-design challenges in providing interpretability of synthesis? That is, do we need to nicely show information that's already available in the synthesis tool, or does the underlying tool need to be changed to enable more information?
So my understanding is that for the interpretable synthesis, we did have to add some, listeners essentially in on the process internally. So there was the underlying synthesis tool was not the same exactly, but there was not. I don't believe that the process of the synthesis changed. Right? It was we could nicely show with those augmented kind of almost like export functions periodically as it was thinking what was happening, but I think it would be a really cool direction to ask ourselves, if we were open to more significant modifications of the underlying synthesis, what would we want to show? What information can we not yet just nicely show from the existing process that would really help people with low energy kind of tap that synthesis in the direction, no, this is what I meant. You're a little off track. That would be a fun future paper.
Wonderful. So with that, we conclude the keynote and our question and answer session. Another big round of applause, please, for
Thank you for
Elena.
having me.
Yes, this is very cool. Technology is kind of amazing, even when it's broken, but we have to appreciate what's good about it. And I really appreciate your being here. This has been wonderful. And thank you all for the conversation and questions.
Thank you, everyone. Nice to meet you all.
Excellent. So this concludes the keynote session, but at this time, virtual dinner will be beginning in the lounge. So make your way to the lounge, and you may get to talk to others about everything that you've seen today so far. And some of you may want to go to bed, but we'll see you soon, and thank you very much.